Hello. Okay, so basically, in this video, I'm just going to describe how I presented things in this PDF, as well as just kind of go over some of the things we went over recently. So, as you see, we went over recently, there are a couple ways that we could solve for x. So, if the equation is factorable, we can factor this equation. If possible, we could also complete the square. And in other ways, we could also use quadratic formula. So as you can see here, if you noticed, each of these examples, they are all the same problem, just solved different ways. So x squared minus 2x equals 48. This is x squared minus 2x equals 48. And this one on the bottom here is also x squared minus 2x equals 48. Okay, so all these methods I have gone over in some shape or form in class. But basically, this one here, what you could do is, so if you subtract 48 on both sides, you realize this equation is factorable and you could solve for x. So that's when we can solve for x. You can factor this equation. If we come down here, you could also complete the square. If you realize this term is negative 2 and do all the little steps, when you get down to this step, you need to separate it. So x minus 1 equals 7 and x minus 1 equals negative 7, and just solve for x. This one, you need to be able to identify how you can use the quadratic formula, right? So what we have is, if you subtract 40 on both sides, you need to identify a as 1, b is negative 2, and c is negative 48. Plug everything in and just kind of follow all of those steps that you've seen. And as you see here, this is all the same, like x is 8 and x is negative 6, x is 8, x is negative 6, and we also get x is 8, x is negative 6. So it just so happens that this equation can be solved 3 different ways, as well as this one. So all of these here, so this is the same problem, this is the same problem, and this is the same problem. So look at that PDF and see how I can review some of these things as well, if you don't quite understand. So this one can be solved by factoring, this one can be solved by completing the square, and this one can be solved by using the quadratic formula. Okay. Now, the thing about this is that not all of these problems can be solved each of the ways. In some cases, some methods are going to be better than others. In some cases, only one method can be used. Let's see. So if I go down here, so it just so happens here. So if we factor, we can factor this. Remember this? We can use the x method on this. If we use the x method on this, then what we can see is we can set each of these equal to 0 and then solve for x. And then basically, because we can factor this, we're able to solve for x. This one is a little bit tougher. This one, if you actually complete the square, you'd have to add 5 to both sides, and then if you took out a 6, then it would be like you'd be dealing with x squared plus 7 divided by 6 times x. It's going to be super messy. So this kind of equation, I would not advise using completing the square, especially even because this is an odd number. Because this is an odd number here, usually this would be a case where, okay, well, I want to try to see maybe if I can factor it. And even if I forgot how to use the x method for any other, like the more complicated examples, for me, I just be like, oh, I can just use quadratic formula and I can get there. So you can just use quadratic formula, as you can see, and you can just get your answer. Okay, so I'm going to keep going down. So this one is an interesting case. So this, now, like I showed you in class, especially when I was going over those harder complete the square and quadratic formula examples, we started seeing things that are not factorable. So for example, if we subtracted 4 on both sides, what we're going to realize is this equation is not factorable, because if we make our list of numbers, 1 and negative 4, negative 1, 4, 2 and negative 2, 1 plus negative 4 is negative 3, negative 1 plus 4 is 3, 2 plus negative 2 is 0. None of these numbers add up to 8, so this equation is not factorable. So we cannot solve for x by factoring. We can, though, complete the square. If we have this example here, we can complete the square and still solve for x, as well as use the quadratic formula. So we can use the quadratic formula here as shown in order to solve for x. Okay. Now if I go all the way down, this is where it gets a little bit hairy. Yeah. So actually, so this one, let's look at the top one. Look at the top one here. You add 8 to both sides. If you try to make your list of numbers, trying two numbers multiply 8, add up to 7. What's going to happen is make your list of numbers here. 1 plus 8 is 9. Negative 1 plus negative 8 is negative 9. 2 plus 4 is 6. Negative 2 plus negative 4 is negative 6. So since none of these numbers add up to 7, you cannot factor this equation. So you cannot solve this problem by factoring, or solve for x by factoring. You can use completing the square on this. It's just really messy. And actually, this is something I'll save for Unit 3. I won't test you on this for Unit 1. But yeah, you could essentially use complete the square. But again, since this b term is odd, I wouldn't recommend using completing the square. Because, yeah, you're going to get like 7 divided by 2, and then 7 divided by 2 squares, 49 over 4. And it even goes over some concepts that I know I haven't described yet. I know I have taught it in my geometry classes for those that have had me for geometry, but I cannot make that assumption for anyone that has taken Mr. Cam or Mr. Hashi or Mr. Sabato. So that's why I can't really test you guys. I don't want to test you guys on this until you guys are solid with or more solid with the jail the partners in crime in the jail cell and whatnot. I want that to be kind of solid first before I go over certain kinds of examples as shown. So what that means is, so as you come up here, if you try to solve this, you cannot factor it. So because it cannot be factored, then you want to consider completing the square. Since this b term is odd, maybe it's not the best idea to complete the square. So by default, your last resort will be to use the quadratic formula. And basically, as you see here, you can use quadratic formula to solve the problem. Okay. Now, what I'm going to mention is just some things, just some interesting things, just to kind of summarize. Okay. So basically, as you've seen in the video, if you cannot factor the expression, you want to consider completing the square or quadratic formula. In most cases, yeah, I would say that if the b term is odd, just use quadratic formula. If completing the square has some ugly fractions, so if you're trying to do it and you get some really ugly fractions, you can consider factoring. And if it can't be factored, well, factoring is just out of the question. And then you have to use quadratic formula. So if you kind of saw a pattern with these, you can, as long as you have an equation in the form ax squared plus bx plus c, and you get the right side equal to 0, or even if you rearrange these terms and you put them on the right hand side and you get the left side equal to 0, you can use a quadratic formula. So any equation that can be written in this form can be solved by using quadratic formula. So if you guys like to hear me sing again, so x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Alright, so that just kind of gives you a summary on how to read that PDF. Okay, so please let me know if you have any questions on anything, and that is it. Okay.